Hey everyone, it's Miss Joyce. Today we'll be adding and subtracting mixed numbers with unlike denominators involving regrouping. Let's start by adding 2 and 2/3 plus 3/4. Well, if we look at these two fractions that we're adding, we notice that the bottom number, the denominator, are not the same. So we need to create equivalent fractions so that the bottom numbers are the same, meaning that they have the same size pieces. So what we're going to do is list out our multiples of 3 and 4 since those are our denominators. We'll start with 3 since that is our first denominator. We have 3, 6, 9, 12, and 15. We'll do the same for 4 since 4 is the denominator of our second fraction. We have 4, 8, 12, 16, and 20. When we look at both of these lists of multiples, we can see that 12 is the first number that can be found in both lists. That means we're going to rewrite both of these fractions so the denominator is 12. So let's start with 2 and 2/3. We know that our denominator is going to be 12. Now let's ask ourselves, what do we multiply by 3 to get to 12? Well, 3 times 4 gets us 12. So since we multiply by 4 on the bottom, we're going to multiply by 4 on the top. 2 times 4 is 8. The whole number 2, which is in front, stays the same because we still have 2 wholes, we just have smaller pieces now. Let's do the same for 3/4. We know the denominator is going to be 12. So let's ask ourselves, what do we multiply by 4 to get to 12? Well, 4 times 3 gets 12. So we're going to multiply the numerator by 3. We see that 3 times 3 equals 9. So 3/4 is equivalent to 9/12. Now that both of these denominators are 12, we can go ahead and add these fractions together. 2 and 8/12 plus 9/12 equals, we're going to start with the fractions, 8/12 plus 9/12 equals 17/12. Notice the denominator stays the same because there's still the same number of pieces in each whole. Now we can add the wholes. 2 wholes plus no wholes is equal to 2 wholes. So we have 2 and 17/12. But if you look here, the numerator 17 is bigger than the denominator 12. That means there's at least one whole within this fraction. We are going to break apart or spread out each of these whole numbers and fractions to see if we can take out another whole. So we're going to add 2, because that's the whole number in front, plus 12/12, because that is equal to one whole. So we're going to be taking out this one whole from the 17/12. Well, now let's ask ourselves, if we've taken out 12/12, what do we have to add to get to 17/12? Well, we need to add 5 more 12s. So here we have 12/12 plus 5/12. That gets us our 17/12 here. We rewrote this as 12 over 12 because we can say that's the same as one whole. So now we have 2 plus 1, which is 3, plus the 5/12. So our sum is 3 and 5/12. Let's try another one. Here we have 3 and 4/5 plus 1 and 2/3. When we look at these fractions, we notice the denominators are not the same. So we need to create equivalent fractions. To do this, we're going to list out our multiples of each of the denominators. 5 is the first denominator, so that's why we're going to list out the multiples of 5. We have 5, 10, 15, 20, and 25. We're going to do the same for 3, since 3 is the denominator of our second fraction. We have 3, 6, 9, 12, and 15. When we look at both of these lists of multiples, we can see that 15 is the first multiple that can be found in both lists. So we're going to rewrite each of these fractions so the denominator is 15. So let's ask ourselves, what do we multiply by 5 to get to 15? Well, 5 times 3 gets us 15. So since we multiply by 3 on the bottom, we're going to multiply the numerator by 3. 4 times 3 is 12. We notice the 3 wholes in the front stays the same. So 3 and 4/5 is equivalent to 3 and 12/15. We're going to do the same thing for 1 and 2/3. The denominator is going to be 15. Now let's ask ourselves, what do we multiply by 3 To get to 15, well, 3 times 5 gets us 15. Since we're multiplying by 5 on the bottom, we're going to multiply by 5 on the top. 2 times 5 is 10, and the 1 whole in the front stays the same. If we look at these equivalent fractions, they both have a denominator of 15. So we can go ahead and add these fractions together. 3 and 12 fifteenths plus 1 and 10 fifteenths. Start by adding the fractions. 12 fifteenths plus 10 fifteenths is equal to 22 fifteenths. Now we can add the wholes. 3 wholes plus 1 whole equals 4 wholes. So we have 4 and 22 fifteenths. But if we look at the fraction, the numerator 22 is bigger than the denominator 15. That means there's at least 1 whole that's inside this fraction that we can take out. So let's break apart our whole number and fraction. We have 4, because that's the whole number in front, plus we're going to take out 1 whole, which is 15 fifteenths. Now let's think, what do we add to 15 fifteenths to get to 22 fifteenths? Well, we add 7 fifteenths. Remember, 15 fifteenths is equivalent to 1 whole. So now we can go ahead and add these whole numbers and fractions together. 4 plus 1 is 5, plus 7 fifteenths is 5 and 7 fifteenths. So the sum is 5 and 7 fifteenths. Now let's try a subtraction problem. Here we have 1 and 1/5 minus 1/2. Well, if we look at these two fractions, we see the denominators are not the same. So let's create equivalent fractions. We can do this by listing out our multiples of each denominator. Let's start with 5, since 5 is the denominator of our first fraction. We have 5, 10, 15, 20, and 25. We'll do the same thing for 2, since 2 is the denominator of our second fraction. We have 2, 4, 6, 8, and 10. If we look at both lists of multiples, we can see that 10 is the first multiple found in both lists. So we're going to create equivalent fractions where the denominator is 10. So let's start with 1 and 1/5. We know the denominator is going to be 10. So let's ask ourselves, what do we multiply by 5 to get to 10? Well, 5 times 2 gets 10. So since we're multiplying by 2 on the bottom, let's multiply by 2 on the top. 1 times 2 is 2. So here we have 2 tenths, but don't forget about the 1 whole in front stays the same. So 1 and 1/5 is equivalent to 1 and 2 tenths. Let's do the same for 1/2. We know the denominator is going to be 10. So let's ask ourselves, what do we multiply by 2 to get to 10? Well, 2 times 5 gets 10. So since we're multiplying by 5 on the bottom, we need to multiply by 5 on the top. 1 times 5 is 5. So 1/2 is equivalent to 5 tenths. If we look at both of our equivalent fractions, we see the denominators are the same. So now we can go ahead and subtract. We have 1 and 2 tenths minus 5 tenths. Remember, always start by adding and subtracting the fractions first, because that's the smallest part of the number. Here we have 2 tenths minus 5 tenths. Well, if we only have 2 tenths, we can't take away 5 tenths. We need to regroup. So we are going to regroup from the whole. What we're going to do is rewrite this mixed number as a fraction greater than 1 so that we can subtract the fractions. To do this, what we're going to do is multiply the denominator times the whole number. So we have 10 times 1, which is 10. And now we're going to add the numerator. So we had 10 times 1 is 10, plus 2 is 12. So the numerator is going to be 12, and the denominator 10 stays the same. So here we have 12 tenths. Now we can subtract 5 tenths. 12 tenths minus 5 tenths equals 7 tenths. So 1 and 1/5 minus 1/2 is equal to 7 tenths. Let's try one more problem. Here we have 2 and 2/4 minus 1 and 4/5. So if we look at both of our fractions, we can see that the bottom number, the denominators, are not the same. So we need to create equivalent fractions. To do that, we're going to list out our multiples of each denominator. Starting with 4, we have 4, 8, 12, 16, and 20. Now let's list out our multiples of 5. Here we have 5, 10, 15, 20, and 25. When we look at both of these lists of multiples, we can see that 20 is the first multiple in each list. So 20 is going to be our common denominator. Let's rewrite 2 and 2/4 where the denominator is 20. We need to ask ourselves, what do we multiply by 4 to get to 20? Well, 4 times 5 gets us 20. So since we're multiplying by 5 on the bottom, let's multiply by 5 on the top. 2 times 5 is 10. But don't forget our whole number 2 stays the same in the front. So 2 and 2/4 is equivalent to 2 and 10/20. Let's do the same for 1 and 4/5. We know the denominator is going to be 20, so let's ask ourselves, what do we multiply by 5 to get to 20? Well, 5 times 4 gets us 20. So since we're multiplying by 4 on the bottom, let's multiply by 4 on the top. 4 times 4 is equal to 16. Don't forget about the whole number 1 in the front stays the same. If we look at our equivalent fractions, we can see that both fractions have a denominator of 20. So we can now subtract these fractions. 2 and 10/20 minus 1 and 16/20. Remember to always start by subtracting the fractions first, because we want to start by subtracting the smallest place value. We have 10/20 minus 16/20. Well, if we only have 10/20, we can't take away 16. So we need to rewrite these fractions or mixed numbers as fractions greater than 1. To do that, we are going to multiply the denominator 20 times the whole number 2. 20 times 2 equals 40, and now we're going to add the numerator on top. 40 plus 10 is equal to 50. So the numerator is 50, and the denominator 20 stays the same. We're going to do that for the same thing for the mixed number here. We are going to multiply the denominator 20 times 1. So 20 times 1 is 20, and then we add the numerator on top. So 20 times 1 is 20, plus 16 is 36. So the numerator for a fraction greater than 1 is 36, and the denominator 20 stays the same. Now we can subtract 50/20 minus 36/20 equals 14/20. So our difference or answer to a subtraction problem is 14/20.